Problems 1 through 5. We want to evaluate for the given values of -2 and 3. Which one of these do we want to look at? Number 2. 7 times 2 to the x minus 3. Yes. So we can say 7 times 2 to the -2 minus 3. And then we're also going to do 7 times 2 to the third minus 3. So we're going to type them in exactly as we see them, just replacing x with 2. So 2 times 2 to the -2 minus 3 is -5/4. And then we can do the same. 7 times 2 to the third minus 3 is 53. If it gives you a decimal number, round to the third place. If it doesn't, write the whole thing out. Because the first one, 16 to the 3 plus 5, it is 429496726. We would need the whole thing. Because the first one, number 1, 16 to the 3 plus 5, that whole thing is the answer. Because we don't have a decimal, we're not going to be able to round to 3 places after the decimal. So it is that entire number.
That is which one?
Number 1.
I just typed in here to get me a Mountain Dew, and then Slate brought me back.
All right. So let's see here. Number 1. So 16 to the 3 plus 5 is 429496726. So 4,294,967,296.
That is great.
And we can go on and look at this. Yes. I only write the commas if I'm going through and pronouncing all the unit markers, the thousands, millions, billions. Now, 16 to the -2 plus 5. Let's see here. Yeah. There's a way to switch between it, but 16 to the -2 plus 5 is 4,096. All right, guys, let's focus in. Questions on 1 through 5? We good with 1 through 5? And it might be handy to put the parentheses around the number when you plug it in, just in case there's multiplication or a negative, but I would just type it in as you see it. So any other questions on 1 through 5?
Can we go over 3?
You just
Oh, you plug it in. Sorry.
wait. Like what I was wondering was like, do you plug it into the 5x? Okay, so you do. That's all I was wondering.
Yep. And at this point here, we could type the whole thing into the calculator. And the other is going to be 32760. So when we type it in, these are our two answers. Now, if you do get a decimal with rounding and you're not sure if you're rounding it correctly, just go on and give me more places. Don't round it, just give me 4, 5, 6 decimal place numbers after the decimal. Or you can just write the whole thing out. Either way works. It is, as long as you don't round. Because if it's 1/3, or let's say 2/3 is 0.666, and you do the line here, you can't put a 7. Because you either have the repeating bar or the rounding. You're not going to do both. 6 through 11, tell whether the function represents exponential growth or decay. I was planning to have these on the test, wrote the tests, and then realized it's not on there. Yeah, I forgot to put those on there. All right, guys, next thing we're looking at is logarithmic to exponential. So we're changing it from logarithmic form to exponential form. Now, if we look at this first one here, if we did the changing method we started with, our b, our base is 9, and it would be to the, all right, guys, to the fourth is equal to 6,561. That's it. Now, the other way we could have done this is we solved this, especially when we did finding the inverses. We could put both sides to the base of 9. We choose 9 because the logarithm's base is 9. Because 9 to the log base 9 of 6,561, the 9 and log base 9 cancel, leaving us with our 6,561. The other side is 9 to the fourth, getting this here. I just put both sides of the base of 9. And it's simplified to our 9 to the fourth is equal to 6,561. What would 13 be?
5 to 7 equals 7, 8, 1, 2, 5.
5 to 7 is equal to 78,125. Yep. Questions on this here? Yeah.
I was wondering why I was going to put it's a fraction.
They don't necessarily need it because we could have them. It's to signify that number and only that number's inside. Now for 14, it'd be what?
1/7 to the negative first power equals 241.
401. Well, before we get to 16, let's go on and do 15.
15 to the 1.
Are we good with colors? We can see all the colors easily? Okay. If at any point one of the colors comes up there that you can't see, tell me. Because I can't. It's hard for me to judge when I'm standing less than a foot away from it. So we good with doing these here? Yes, with LOG. 16, ln of x equals 7. What would this be?
The ln of 7 equals x.
Because what's our base? E to the
7.
because even though it's not written, the base is understood to be E.
Oh, are you doing it on both sides as well? Again?
Because this is just, the one in green is just the base, because it's the natural log base E of x. If we applied E to both sides, E and the ln will cancel, giving us E to the 7 on one side, and the other side would just be x. Let's look at number 17. What would it be?
E to the y.
E to the y equals 6. Number 18. 19.
You said a 9.
And that's it. Questions on 16 through 19. We feel good with these here. One. And it's the inverses. Finding the inverse 41 through 50 on the review.
We're going to do that together?
Yes, if we do have time. Was there a question? Okay. 20 through 25. Rewrite each equation in logarithmic form. So we're going the other way around. So on the last set, we went from exponential to, or from logarithmic to exponential. Now we're going from exponential to logarithmic. What would the first one be? Log base 3 of is equal to. Because we're going to say we're applying log base 3 to both sides. Because we'd have log base 3 of 81. And our log base 3 of 3 to the 4th would just reduce to 4. Number 21.
Log base of 1/5
So log base 1/5 of 1 over 125 is equal to 3. 22. Log base 125 of 25.
Is it not log base?
Log base 125 of 25 equals 2/3. Questions? Okay. So we feel comfortable with these here. How about 23? What would it be? ln of x equals 4. We don't have to write the e because it's understood. Because the base is indeed e, but with natural logs, it's always e. There's never going to be any time it's not. So we just have this here. 24.
Natural log times 27.
So natural log of 27 equals y. And the last one. That one's kind of nice. Because that's what we wrote, I think, at the beginning, yes? The natural log of y equals x if and only if e to the x is equal to y. Questions on this here? (26), 27, 28. Evaluate each logarithm and round to 3 decimal places. Now the first one, 26, we could use the change of base or we can just use the graphing calculator. Because in the graphing calculator, if we hit math and go up to log base, enter 5 over alpha y equals enter gives us fraction. 1 over 125 is -3. Now the next one, log base 9 of 2,187. Now we could technically do the change of base. And the change of base was log of what's inside of it over log of the base. 7/2 or 3.5.
Wait, how did you do log of 5 again?
Math, log base. And then we can type it in. You're welcome. It's only on the graphing one. Yep. Math, log base. So scroll up or down. And then we'd say 9, 2, 1, 8, 7.
Okay.
Alpha, y equals. Enter. If you do have trouble finding it, like for 1 over 125, well, that's the same as 1 divided by 125, yes? So you can do division too. All right, guys. Now, it said to round to 3 decimal places. Well, does the first one, -3, have any decimal places? No, so there's no reason to round. 3.5 doesn't actually have 3 decimal places given. We could round to it, but that would just be 3.500. No reason to do that. Last one, math. Log base 10 of 0.12341 is -5. If the number doesn't have a decimal or it doesn't go out 3 spots, I'm not expecting you to give me 3. Natural log of 27. Either calculator does have the natural log button. So we can hit ln of is 295836866. And so 29.3.296. It gave us more than 3 decimal places, so we rounded to the 3rd decimal place. Number 30. ln of 2 over 7. Negative 1.253. We good with all this here? Last one, natural log of 4 to the 6th. And especially with these here, I would type them in exactly as you see them. Exactly as they show up on the test. Type them in exactly the way they are. Here, 8.318. And that's it. Questions on 1 through 31. We good with 1 through 31. 32 through 35. Expand. Quotient. Product. Power. The properties we're going to go through. Whenever we expand, the first one we use is quotient, second one's product, third one is power. Now, if one of them is not needed, we don't use it. Most likely out of these 3, quotient or power is one of the ones that wouldn't be used. It's either A, there are no exponents, so we don't have to do that, or B, there is no division to start with, so we don't need quotient. Which one do we want to look at? 33. Log of 7x squared over y to the 3rd z squared. Quotient is first. Whenever we have something being divided inside the log, we can rewrite it as 2 logs being subtracted. The first log will contain what's on top. The second log will contain what's on bottom. If it's on top, it's going to be positive. If it's on bottom, it's going to be negative. What's on top? So their logs will be positive. What's on bottom? Y to the third and z to the second. So their logs at the end will be negative. Yeah. Now when we do the product, log of 7 x squared, since we have two things being multiplied inside the log, we can rewrite them with addition. Now it's going to be log of 7 plus log of x squared. Now I'm going to write this out. You don't necessarily have to write this out, but we could say minus. And again, our log, a different color for this here, of y to the third z squared would be log of y to the third plus log of z squared. But again, we have that negative out in front of both. So that negative has to be applied through. So it'd be log of 7 plus log of x squared. And we'll get there, yes. But this log of y to the third would be negative, and so would the z squared. That's why they're both negative. Because it is plus, the property does split log of y to the third z to squared with plus. But because it was in the bottom of the fraction, that negative out front, this negative out front, had to be applied to both, so they both ended up being negative. That's why. We don't necessarily have to write this step out, especially if we see that these are both going to be in the bottom. They're both going to be negative. We could take that middle step out. Questions on this here before we do powers? Powers are just moving in front. So it would be log of 7. The 2 would move up front, telling us plus 2 log of x. Minus the 3 would move up front, telling us it's 3 log of y. And lastly, we move the 2 up front, minus 2 . Questions on this here? You good with this here? Yes? Any questions on any of this so far? Over here. Which one do we want to look at next? 34. Quotient first. So our logarithm of the top minus the logarithm of the bottom. So our first step, after using quotient, we'd have the natural log of 7x cubed minus the natural log of 16y squared. Questions on this here? Now that we finish with quotient, we'll do product. Our ln of 7x to the third would be ln of 7 plus ln of x to the third. Now our 16y squared, natural log of 16y squared. Well, 16y squared was in the bottom of the fraction, so any of the natural logs coming from it should all be negative. They should all be minus. So we have ln of 16 minus ln of y squared. As we could put that in parentheses like we did on the last one and say ln of 16 plus ln of y squared and then distribute the negative. Or essentially we're just doing it all at once. Questions on this here? Now the last thing we have is powers. Ln of 7, the natural log of 7, there is no exponent, there is no power. But for our next one, we'd bring the 3 up front, telling us it's 3 times the natural log of x minus natural log of 16. And lastly, we'd move the 2 out front, giving us minus 2 ln of y. Let me get this here. Questions on any of this here? Yeah. I probably will. No. Well, recognize the first one as a fine touch and then recognize the second as a hard press, because it attaches different things to different ones. So, questions on 32 through 35? Yes. So if we look at 35, natural log of 8x cubed y squared z to the 4th. Is there a quotient? Is there division? With that there? Well, no, right? There's no fraction. So we just skip over quotient. We don't have to do that. We can go straight to product. Let's focus in, guys. All right, guys. Guys, let's focus in. We can go straight to product. Because we have more than two or more things multiplied together inside the logarithm, we can rewrite it as addition of each of those parts. So ln of x plus ln of x to the 3rd plus ln of y squared plus ln of z to the 4th. We have this here. Right. Because we can separate each part. Now from here, we can go to our powers and we can move them to the front. So it'd still be ln of 8 plus 3 ln of x plus 2 ln of y plus 4 ln of z. And that's it. So because there was no division, there was no fractions, there are no minus, there's no negative terms in any of this. Because they only come when there's a fraction. Does that make sense? They're almost a little bit nicer. We don't have to worry about minus or negatives. We good with these here? Yes? Condense. With condensing, we have two main steps, power and then product. Power, then product. And with our power, we take the negative with it. So we can look at 36. So the first thing we would do is our power. We're going to move the number in front back up to being an exponent. So our 6 log of x becomes log of x to the 6th. Plus our 5 log of y becomes log of y to the 5th. Plus our negative 4 log of 3 becomes 3, or log of 3 to the negative 4. Questions on this here? Now, since we have three logs, three of the same logarithms, same base being added together, we can rewrite it as a single log with what's inside being multiplied. And it really takes care of power and product. Now, the last thing we need to do is simplify. If there's any negative exponents, we need to get them to be positive. And to make an exponent positive, so our 3 to the negative 4, we move it from the top of the fraction to the bottom, or from the bottom to the top. X to the 6th, y to the 5th stay the same. We're almost done. There is one last thing, but any questions on how we got to this point here? Because the only thing we have left to do is 3 to the 4th. Is it a nice number? We can plug it in the calculator. It is 81. And when I say nice number, I mean it's not giving it to us in scientific notation. It's not a number with a massively long decimal times 10 to a power. If we get that, leave it as an exponential form. But I believe all the ones on the test where if it's a number to a power, plug it into the calculator and replace it. Any other questions on 36 through 40? Which one do we want to look at next? Because I think we want to look at at least one more, yes? 40? I'm going to fix that. This, yeah, we can treat a variable as an exponent. Yep. And I think it's negative y in it. So we would bring the negative y up to the exponent, do our product, and it would turn it to plus, and then we'd have to move it to the bottom. Here, power first. So we're going to move all of these numbers in front of the logs back up into exponents, which would give us log of 2 to the 3rd plus log of x to the 4th plus log of y to the negative 3 plus log of z to the negative 4. Questions on how we got to this point here? Now at this point here, we have 4 logs with the same base, so for the same logarithm. So we can rewrite it as a single log with what's inside being multiplied. Now for here, where there's a few things we need to fix. The y and z both have negative exponents. So to make them positive, we move both of them from the top of the fraction to the bottom. X to the 4th is going to stay there. And while we're at it, we can do 2 to the 3rd. 2 to the 3rd is what? 8. Our final answer is log of 8x to the 4th over y to the 3rd z to the 4th. And that's it. Questions on this here? Because if we didn't take the powers with it, you don't have to write this. I wouldn't write this. All of this here. There we go. because we would have minus and minus. And to fix that, the first thing we would have to do next is factor that negative out. Then use our product. As we'd factor it out, then use product to tell us that we have log of 2 to the third x to the fourth minus log of y to the third z to the fourth. Now we have two things being subtracted. We can use our quotient product property. Tell us that it's log of 2 to the third x to the fourth over y to the third z to the fourth. Yes. Yes. Okay. But even looking at this here, I still think taking that negative up as an exponent is a little nicer than this.